Hello, Facebook. We're here live at CRTLabs in the Realtor Building, downtown Chicago, Illinois. We're here every Friday, 1 p.m. Central, maybe a little later, depending on our technical difficulties, to answer your questions and just give you an update on what we've been working on. So we don't have any questions right now to get started, so I'm going to go into a project I've been working on, Rosetta Home 2.0. Now this is a little different than 1.0. 1.0 was a cloud-based solution to monitor different consumer devices and some custom devices within your home.
If you were at the convention last year, that's when we launched version 1.0. And as Chris said, with this explosion of the smart home technology with all these different thermostats, lights, locks, air quality sensors, Rosetta Home version 1.0 was created to kind of aggregate all that data into a potentially listing.
Correct. So we did some demos how that would look in an MLS, looking at air quality information, energy usage, different things like that. The new version 2.0 is actually kind of quite a jump from version 1. Made the decision to really focus on privacy, security, and local control, and control being kind of the main aspect of it in automation. So we're working with all devices within the local network. There's no internet required, although you can have internet to upload different data to different sites. But we've got a whole list here. Here you can actually see kind of the back-end system at work of all the different types of devices that we work with. So we've got HVAC, so your thermostats, humidifiers, different things like that. Lighting control for different smart lights, Hue, LifeX, weather stations, media players, so your Chromecasts, your Apple TVs, all that different stuff. And this is all open source. So we're going to have a demo running at Annual this year, so kind of our yearly release. And this is all open source. So this is going to be running on a little Raspberry Pi. We'll have a nice little case for this guy.
So if you're not familiar with what a Raspberry Pi is, it's a single board computer that costs about $35. They have versions that are even smaller that go for about $5. So the point is it's extremely lightweight, can run on almost anything.
And this will be Wi-Fi based and or Ethernet. So it should have all sorts of connectivity options. One of the cool things we're integrating with this is, as Dave likes to call it, the portable toilet. But this is actually a weather station. We get wind direction, wind speed, we've got a rain gauge, temperature, humidity, obviously, barometric pressure, UV and solar radiation. So this gives you a lot of interesting data that you can start to automate your home with. Blinds, lights, your HVAC system based on weather, windows, stuff like that based on rainfall. So really looking forward to getting this integrated and some different things there.
And it'll always work, even if your internet goes down or if the company that you bought some of your hardware from goes out of business, as we've seen, will all still work. Yes,
and again, it's open source, and we're also going to be tying into another product we're building, the Indoor Environmental Quality Monitor. And I think Dave's going to tell you a little bit about that.
Sure. So I've only presented this twice so far. It's a project that we've been working on all summer here. We had some research assistants from the Illinois Institute of Technology come in to help us with this. And it's building our own open source, open hardware, air quality or environmental quality sensor. Now you might be wondering, why is NAR building an air quality or environmental quality sensor? The EPA did a study last year where indoor air quality was 4 to 5 times worse than outdoor air quality on average. And we also spend 90% of our time indoors. We feel that with people focusing so much on their personal health, fitness trackers and wearables, we think that tracking the quality of air in a home is going to be one of the next big things and next big selling points for homes. So this is the device. To give you an idea of its size, I'd say it's slightly smaller than a business card. It has a variety of different sensors on it. It can do temperature, humidity, VOCs. VOCs are volatile organic compounds. Those are things like paint fumes or formaldehyde. Pretty much anything in your home that generates an odor, that's normally a VOC. It can do carbon monoxide, carbon dioxide, light, noise, all sorts of sensors, all on this tiny little board. And we've also designed it using the most accurate but most affordable sensors we can find. So this should be able to be built for about $50 or $60.
So what's the average consumer device for air quality
Right.
testing?
So
Cost?
if you might, some of the more popular air quality monitors on the market are things like a NetAtmo air quality monitor or a Fubot. Those normally go for $150 to $200. We're actually using some of the same sensors of some of those devices, but we hope to be able to do a complete home for that price.
So the goal being, your basement is quite different than your attic or your upstairs or your bedroom when you close your door. The CO2 can really start to build. So the idea is to give you a whole home view rather than just your kitchen or your living room.
Right, and our board is going to have a variety of connectivity options. You should be able to connect to it over Wi-Fi or cellular. Because we're kind of thinking how realtors could use this to potentially sell one of their featured properties. They might not have internet hooked up at that home yet, so we want to add cellular connectivity as well. So we just released it really about 2 weeks ago. It's already the #1 Google search for open source indoor air quality sensor. We're really, really proud of it. It's one of the coolest projects that I've been a part of. We'd like to give a quick shout out to Akram Ali. He's the PhD candidate that I mentioned earlier, who has put in a ton of hours on this, and it's helped really bring it to life. We will be bringing these to the annual convention as well in November in Orlando, so definitely stop by the CRT booth. I believe we'll be in the main Realtor Pavilion.
Booth 208.
Booth 208. Thank you, Adrian.
208. All right.
So back to you, Chris.
Yeah. So we got some updates on another project we've been working on. The Smart Growth Grant Program. We're actually working with Dan Coffey out of New Buffalo, Michigan. Now, this is an interesting project. So the Smart Growth grants are based around the idea of NAR and realtors themselves helping their community grow. So not just individual homes and selling a home, but as we all know, it's location, location, location. So a better community helps raise the value of all the homes in the area. So what we're doing in New Buffalo, they're an interesting economy. They're very boom and bust. They are a heavily tourist economy. So in the summer, they're about an hour and a half outside Chicago. They go from 1,800 full-time residents to 5,000 to 10,000 on any given weekend. So you can imagine the congestion issues and just getting people moving around that town.
Puts a lot of stress on the parking too for local businesses because people from Chicago will be coming into town. Instead of paying for parking at the beaches, they'll be parking in front of businesses and then just walking down.
Which takes away valuable real estate for the businesses and the people that would actually be shopping there. So what we've done, we work with a company called PlaceMeter. They offer some pretty interesting technology, which you can see here. It's using computer vision, so a webcam or anything like that, pipes the data to their system, and then they do analysis here. So as you can see, we're tracking cars, pedestrians. We can actually put turnstiles, virtual turnstiles, in front of each entrance to the business and look at how many people are coming in and out. So right now we're primarily using this for the automobile traffic in the area, looking at how many people are getting off the exits of the freeway, where they're going, and kind of tracking where people are driving within the city for their parking issues.
So the city's going to be able to take this information that we gather over the next year and help make more informed decisions on, where to add parking, maybe where to add meters or where to add parking garages. We've actually done some experiments with this here on North Michigan Ave in Chicago. This is a very busy street out here. We set up a sensor overlooking the street. We have over 40,000 pedestrians walking in front of this building every single day.
65,000 cars go by every day too. So another interesting thing we're doing with our test unit here is that same mobile toilet weather station that we demoed before. We're going to be setting this up as well. So what we'll be able to do is correlate weather information. So if, how much rain did we get, and how did that affect pedestrian traffic versus vehicle traffic? Our early indications show when it's raining, we get more vehicle traffic and less pedestrian. Obviously, people are more in cabs and driving to work. But we can start looking at solar radiation as well. On a hot, sunny day, we're seeing less people, more people. So how does all that work? So it'll be a really interesting kind of mashup of the data there.
It's actually it's very affordable. It's $60 per measurement point.
Yeah, depending on your level.
Per month.
Yeah, so different depending on your level of commercial building. I think it goes up to 90. and that might be based on how many deployments you have.
But one really nice feature of that is you can use existing cameras. You don't need to add additional cameras to gather this information. So we were able to tie into just the NAR building security cameras to get those counts we talked about before.
Very cool, very cool.
It's PlaceMeter.
PlaceMeter.com.
Oh, we have a question.
Yeah.
Would you talk about what open source is and why that's important?
Sure.
Yeah, so we mentioned open source a few times actually. Chris mentioned it with a software product he was building, the Rosetta Home version 2.0. I mentioned it with the hardware product, the actual indoor air quality sensor. What open source means is that all of our designs, all of our code is shared publicly with the world for anyone to implement themselves. There's going to be, the only licensing we have on the products that we create here at CRTLabs is to protect us from other people filing patents on the work we've done. But other than that, other companies, other institutions, or even entrepreneurs or high school students could build this without worrying about any licensing issues.
Another big aspect is, when you open it up and let other people use it, we also look for people to contribute back, right? So from a security aspect, that's huge. You've got, maybe, we're pretty good at security, but maybe, there's somebody better. There's always somebody better. But, you ask them to help contribute to the project, and many hands make light work. And so as we get community support, the product gets better in itself. And there's a great example, Home Assistant. I mean, I think they've got
over 200 developers working on it.
Over 200, and the rate they're able to release updates and new features is absolutely incredible. That a team of 5 people that would not be able to.
So it's a similar solution to Rosetta Home, but again, they're just trying to control every smart home device via one central platform. The creator started it about 2 years ago, but it really blew up around December of last year. And now the person who started the project isn't even in the top 5 of contributors to it. Yeah. So other people have taken it and run with it. Another question.
What is Home Assistant?
So it's another open source software product. It's written in Python for the programmers out there. You can check it out at home-assistant.io. It's actually a really great system. We use it here in the lab to do demos so we can show the capabilities of all the different smart home products. It also runs on Raspberry Pi, like Chris
Raspberry Pi, and a big part of that is the scenes aspect, which if you get into your hubbing technology, you'll sorry, inside joke. You'll see that's a big feature, is this idea of being able to sync multiple devices from different makers to create these scenes. And Home Assistant's got a really great API, I guess.
I think their tagline is really, it's 3 steps. First is observing. So you'll be able to observe the state of all of the locks, lights, and thermostats in the house. Second is to be able to control them remotely. And then the third is the automation, the scene setup, like Chris said.
Yep.
And what type of stuff will the stuff we're working on work with? Like what smart home technologies are already out there that are going to work with ours?
Well, in between, if you combine Rosetta Home 1 and Rosetta Home 2, we probably have support for 20 to 30 devices.
Yeah.
Thermostats, air quality sensors.
So Rosetta Home 2.0, again, internet is not required, so we're trying to not rely on cloud-based providers. The issue right now is there's a lot of walled gardens out there with a lot of the different products. Nest, Google, Apple, all the big guys are really kind of creating these walled gardens. One of our, again, part of the open source initiative is to break down those walls. And so we're really focused on stuff that we're allowed to control locally. So it does limit us right now, but there's a good amount of products out there. So we've got Wemo, Chromecast, Apple TV, LifeX light bulbs, Philips Hue, a couple different thermostats, energy monitors. So we work with Nurio, which does energy monitoring,
Rainforest Automation.
Rainforest Automation, which will actually talk to your smart meters, whether that's electric, gas, or water, and give you real-time information on that.
And as soon as these vendors open up their APIs, we're adding them as quickly as we can.
Yeah. And if you know of any other products out there that you'd like us to check out, please let us know, because we are willing and ready to implement.
And if you want to see, if you want to learn more about any of this work we're doing, you should check out our blog, CRTLabs.org. Also follow us on Twitter at CRTLabs.
And you obviously already follow us on Facebook, but good for you. If you don't, tell your friends.
Yep. So thanks again for visiting us during our office hours. We'll be doing this again next Friday, 1 p.m. Central.
With no technical difficulties.
Well,
No problems.